Hi there friends and fellow viewers. Yeah, Steve here, and today I'm going to talk about mathematics and number systems. Yeah, it's another curious thing. When you ask somebody how many fingers have you got, people say, oh yeah, I've got 10 fingers. If you ask somebody how many thumbs have you got, they say, I've got 2 thumbs, and how many fingers have you got? I've got 8 fingers and 2 thumbs. So what is it? Well, if you go online or whatever and have a look around, you'll see, oh yeah, we count to 10 because we've got 10 fingers. Well, I remember in the 70s, people counting in 12s, there was 12 inches to a foot. The decimal system in England, I don't think came until 72 or something. We're still counting in weights and measures, and time is in different bases, base 12, base 60. Essentially, it's a lot to do with the number 6. 6 is not an evil number. 6 is a very good number. 1 plus 2 plus 3 is 6. 1 times 2 times 3 is 6. That's where we get the 12, and that's where we get the 60. A lot of people ask me, well, how does a base 12 work? Well, we use base 12 in time all of the time. Everybody knows that there's 12 hours and then it goes to 1, or there's 24 hours. So we don't work in base 10 when we're working with time. We know there's 60 seconds in a minute and 60 minutes an hour, 24 hours in a day. So we're very used to realizing that when it gets to 59, you go over to 1 minute. You don't say, oh yeah, there's 60 seconds. You say 1 minute. You can say 90 seconds, whatever. So 12 is an interesting number because obviously when we get to 10, we don't say 1 teen, 2 teen, 13, we say 11 and 12, so there's 2 words extra for those two numbers. So there's something there. And so the problem with the 10, I've been looking at the Maya calendar and a lot of Maya mathematics, and Mayas were really fascinated by numbers, or they were very clever with numbers. They had amazing calculations, and they used to count in base 20. And I read recently on a certain internet page that the Mayans counted in 20 because they used fingers and toes. Well, for starters, you can't really count using your toes. And secondly, I've seen old Maya like scrolls and stuff where they're kneeling down and counting. And if you kneel down, you can't see your toes. And the other thing is, it's just rubbish. We don't count on our fingers because of 10. 10 is a system. The other thing is, if you look at 10, there's there's 10 numerals, 0 to 9. So if you count in, like, you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a finger missing. Just like Frodo. So where's that number gone? Well, I was looking at the Maya mathematics, and I noticed that they count with like sticks and stones and use a shell as a naught, as a placeholder. Really, I don't think they have a naught like we have a naught. And they have, like, a stone is equal to 1 and a stick is equal to 5. So I was looking at my hand and going, okay, you've got 4 stones and a stick, and so you can count really easily to 9 on each hand, so 1, 2, 3, 4, 5. No, sorry, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 40, 50. So you've got 51, 52, 53, 54, 55, 56, and so on. So you got like 99. That would make sense to me. What's the 12 all about? Well, 10 is actually kind of not really that much use. You can only divide 10 by 2 and 5. Whereas 12 you can divide by 1, 2, 3, 4, and 6. So 12, being a kind of a relation to a base 6, is a universal number. The Babylonians apparently used base 60. It's an old system of counting. And sure, 10 is there for a tool. It's like a kind of tool for counting, but it's not really necessarily the best base to count in. You know, if you count in eggs, you got a dozen eggs, you know, or half a dozen eggs. You know, okay, these days they do sell it in tens, whatever. Well, back to the 12, you know, the thing about 12 is it's interesting because us guitar players, we've got 4 fingers and 2 thumbs. We don't have 10 fingers really, you know, because we have 4 fingers here, you know. You don't see 5 fingers like that. You can use your thumb over the top, but it's just, same with the right hand, you have 4 fingers and a thumb. And you've got 12 notes in an octave. But the thing to remember is that when you play an open string with no hands, that's fret 0. So fret 12 is actually the 13th note. The octave is the 13th note, which is, you know, it kind of indicates where the Mayas were using 13. But I'll explain that in a second. You know, we've got these 12 notes here, and the universal cosmic law really is the law of the overtone series, which is if I play a harmonic, which means I just touch the string at certain places dead lightly, the note rings. Now these notes, they're not really there because of the guitar or the string, they're a cosmic law. The notes only appear in these places. You notice it changes and it goes dead at certain places. Well, these notes are very important. This is the exactly halfway on a string, and then we've got a fifth, a third way of the string, and a quarter. And these are octaves. Okay, so we have these notes, and so this one's a very important one as being the octave, and this one's a very important one. And so there's frets put on these places because it makes it harmonically more perfect to have these overtones that are a natural cosmic law. You know, we hear the overtone monks doing these overtone singing. The notes that they're actually getting are these cosmic notes, if you like. You know, it's basically just a universal cosmic law, and it's a bit like a golden ratio of you know, pi 3.14 blah 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 blah, goes on forever. We haven't got a good calculation for how to work out this cosmic ratio. So we put in these 12 notes to kind of make a best fit with these notes here. But they're not all 100% perfect. In fact, the only ones that are perfect is the octave and this note here, which is the 7th fret or the 5th. So without getting too complicated, yeah, we've got these notes which define the 12 notes here. And like I say, it's a kind of very close compromise. Maybe you've heard of Bach, J.S. Bach. He made the well-tempered piano. It's like he reinvented the way that a piano should be tuned, so that the compromise was better. Because if you tune this exactly harmonically, the frets would be in slightly different places, and you could play a perfect harmonic song, but only in that one key, which means that you would, as soon as you went to another key, it wouldn't work on that one string. So that means that this 12 notes is a good compromise for all of the keys. If you wanted to be perfect about things, you'd have to build an instrument that had 12 different strings that were all the same note, sort of thing, to get the ultimate perfect thing. So the Maya calendar's got 13, and this is something I'm questioning. Maybe you've got some answers for me on this, if you're good at that. In the Maya calendar they use like a circle within a circle within a circle. The smallest circle's got 4, which is 4 days, and the next circle's got 13, which is 13 tones, which is interesting because the 13th tone is, I think they call it, or it's been called an overtone, the overtone or something, which would indicate that it's like kind of the octave. I pondered, why isn't it just 12? Why doesn't it go around in a circle? Well, the thing is, if you use 13, it means that you kind of, it kind of spirals through all of the 12 12s until it goes back round. So 12's quite close, but it's still not, like, it's still not 100% perfect. I'm not sure if there is a system. You know, this is something that I've been researching, and I think it's like a natural cosmic law that we're just not going to find out yet. Maybe we're just going down the wrong path or something. Maybe I am. But definitely, you know, 12 is a much better number than 10, especially for a musician. If I was to tune this guitar so that the 10th fret was then an octave, the whole thing would sound out of tune to anybody, to everybody. There are other musical systems that use more than 12 notes. There's I don't know. There's all kinds of scales, and some of them are really good. Pierce-Boulon scale and Pythagorean scale. Lots of scales and that. You know, a sitar's got, I think, 18 notes or something on it, and basically there's the main notes with notes in between notes. So you've got divisions of notes to give it more harmonic perfection. If you imagine, like, you know, a cake is round, or pie or whatever. You know, I've got a nice round thing here just by accident. If you was to cut that and try and cut that into 10 pieces or 5 pieces using our normal 10 finger paradigm based 10 system, you'd have a really tough job. You know, so if you went to grandma and she made an apple pie, what's she going to cut it into? She's probably going to cut it into 8 pieces, you know, like 1 slice, 2 slices, 3 slices, 4. You know, you've got 4 slices, gives you 8 pieces. Or if you slice it 3 times, you've got 6 pieces, you know, which is quite easy. So you can carry on, and it's much easier to cut a cake into 6, 8 or 12 pieces than it is 5 or 10 pieces, you know. And that's why we use like weights and measures. It's very much easier to to cut something, to divide something by 1, 2, 3, 4 or 6. Money used to be in base 12 or base 6 systems. You know, you had 6 pence to a whatever. You know, I'm too old to know that. You know, that was before my time. But money, weights and measures, everything. And it's because you have this ability to cut it into 3 parts, simple as that. And so in the world of music, you know, 12 is much more relevant than 10, you know, even with the fingers and stuff. And base 20 is based off binary, really. You've got a doubling circuit, because obviously octaves, if you know about octaves, it's quite simple really, but this note is vibrating double as fast, twice as fast as this note. This note is resonating double as fast as this note. And so if you was to add that, you know, you've got like you can say start with like 20, 400, 8,000, you know, that's the way the Maya base 20 counts. So, you know, it's always like doubling and going up in this 10 system. So you're using a combination of the doubling mathematics and base 10. So I'm going to wrap this one up because it's been probably really highly complicated and I've been speaking too fast and whatever. So, but yeah, if you've got any thoughts on mathematics and what I've been going on about, let me